few housekeeping stuff. We invited everyone who registered on Eventbrite to our Slack channel. There are a few people have not accepted, but we will use Slack channel as our main communication platform. So if you have not accepted our invitation, we might also post links on there during the class. So it's probably a good time for you to accept our invitation and join Cadasa's Slack channel. So about 2/3 of the people there. So a few more, 2-3 more minutes. We have about 57 people join us, and we're about like 65 registrations. So majority of the people who sign up for this course are there. So we're just gonna to start. Good afternoon, everyone. Welcome to the first class of the Machine Learning Bootcamp. That is co-hosted by the GDG Cloud Edmonton and the Calgary Data Science Academy. We are really looking forward to learning and discussing the data science topics with all of you for the next 6 weeks. So I am a volunteer from GDG Cloud Edmonton and also one of the organizers for this machine learning bootcamp. Before we jump into our first class, we want to briefly introduce who are we and why we organize this course. So GDG Cloud Edmonton is an official chapter of the Google's worldwide network of developers and data scientists. So when you join GDG, you become a member of Google's global network of over 500,000 developers in over 130 countries and 900 cities. So no matter where you are in the world, you will be likely find a GDG in your city. So a little bit about GDG Cloud Edmonton. Now currently, we have about 480 members, and our members are include cloud developers, data scientists, and architects. And volunteers are the heart of our team. And we have a team of passionate developers and volunteers who have helped engage the local communities through their expertise in tech and in leadership and also in event organizations. And also marketing. So we are pretty young and pretty new organization, founded a year and a half ago. We're still growing, but we're one of the fast growing developers community in Edmonton. And we're always looking for people to join our leadership team, our expert group, and to help us build the local developers community. So in the past year, we have organized over 20 events, including those Google campaigns to learn about Google Cloud, Flutter, Firebase, and Android. We have also built programs such as study jams to learn about machine learning. So this course is really exciting. This is our first course in our course program, and we're so excited to team up with Calgary Data Science Academy to have to present and prepare this course together. And in the future, we're gonna having more courses coming from the two of our groups. And I'm gonna hand over to Lei to have a little bit introduction about Calgary Data Science Academy.
All right. Thanks, Jenny. And yeah, this is our first time to partner with GDG Edmonton, and we're really excited for this. And who we are Calgary Data Science Academy. So when we first started, we're a bunch of data science evangelists, and we're keen to learn data science knowledge. So we formed a study group. So we always having offline events in a library to study some data science topics together. So our key value is we value community and meaningful networking. We also believe that teaching is the best way to learn. So before I jump into details about why we're having this bootcamp and what we want to achieve. So this is a little quiz for you. Maybe you're familiar with SQL, and I just want to ask you to solve this SQL question. Here, when you select all from your summer camp and have an inner join with bootcamp, you're joining on the key, which is people, what kind of result you can get. Let me give you some hint. What do you remember from your last summer camp? Do you remember how to build a tent or start a bonfire? Or do you remember the people you meet there and also the friendship you establish there? Same thing goes for bootcamp. Therefore, when we have an inner join with summer camp and bootcamp, our result is friends and community. Because here we have, during this 6 weeks bootcamp, we're not only learn the essential knowledge on machine learning, we're also meeting people and have the opportunity to work with our course leaders to have that impactful network. So here we are. We have the local leaders from Alberta. So in Alberta, we have people from Edmonton and Calgary. That's why we're teaming up with GDG Edmonton to host such event, because we want to form a Alberta developer and data science community. Here we have our data science evangelists. They are the industry leaders in the data science field, and we also have students who are passionate about data science. Therefore, we're having this machine learning bootcamp. And what do we ask from you? As we said, we're a bootcamp. We're here to form a community. Therefore, we ask you to join us beyond and get connected beyond the lectures. Therefore, we have a Slack channel, which is named as ML-bootcamp-2020. In there, we have our dedicated course coordinators who is going to facilitate some of our discussions and also post some really helpful resources in our channel. And from our course leaders, you'll be able to see some great resources and posting from there as well. So our goal is to get connected with you and all the participants. Hopefully at the end of this bootcamp, you will make some new friends from this bootcamp, and you can connect them with on the LinkedIn or Facebook. And we want to form Alberta's data science community for all of us. Without further ado, I'm going to hand this over to our head instructor, Dr. Daniel Ma, and he's going to kick off our first week's lecture. So I'm going to stop sharing and hand it over to Daniel Ma.
All right, guys, can you hear me, or can you actually see the screen right here?
Yeah.
Perfect. Okay, so welcome to the machine learning program. Before we actually head into the first part of the lecture, which is the EDA, the explanatory data analysis part, I just want to give you guys a general picture of who I am and what a program is about, and what kind of content or what kind of domain of knowledge we actually going to learn from this kind of program. So who is this guy? First of all, you might be wondering who I am right here. So first, I guess the first most important fact about me is that I'm absolutely nerd obsessed with machine learning. I'm a data scientist also working at Statistics Canada. And I'm working on the last term of my PhD program in economics. I had about 6 to 7 years experience on the machine learning and also deep learning kind of related projects over there. So basically what I do is try to combine the economics domain of knowledge and also the machine learning to actually study a bunch of, kind of questions related to consumers' preferences, so on and so forth. And just like all of you guys right here, I'm also a passionate and ambiguous like a learner as well. And also, actually, Lei just mentioned here, I'm the head instructor of the machine learning bootcamp. So again, welcome to this kind of bootcamp right here. And if you guys have any questions related to machine learning or any question related to coding or theory or any question related to programming, you guys are very welcome to actually get connected with me. Just click the link right here. You can get connected with me on, LinkedIn here. Just send out the message and I can see you over there. And also, I just want to mention, I just shared like the notebook version, the website like version, and the HTML version, and also the link to the notebook. So you guys can absolutely click that, open the notebook. So you are welcome to actually follow me to actually go through this first part of this course today. So a little bit of fact about the machine learning bootcamp. So this bootcamp is actually organized by Google developer group, GDG Cloud Edmonton, and also Calgary Data Science Academy. And it's a 6-week lecture. So it's not gonna be a long kind of like a lecture which lasts like 12 weeks where, just like the program or certificate you had in the university. I know that's gonna be a super painful kind of process. So we try to actually reduce this kind of like a, lecture to a really short amount of time period. And each week we're gonna have a 3-hour class. And in each class, we're gonna have 2 parts. The first part is the theoretical part, which is going to give you some kind of theoretical foundation of the models or anything related to that. And after that, we're going to have the hand-on coding part, which is the empirical, hand like coding and also how to actually use a model to realize many different kind of like projects over there. And each week's lecture, we are going to have a dedicated course leader plus 2 course participants. So basically, those 3 people are going to actually form a group, and they are going to lead every single person in the group to actually go through the materials they prepared carefully for each one over there. So the reason for this is like we think teaching is the best way to learn. We want every single person to join us to be part of the lecture, to be a teacher, to teach other people like what you know about this topic. Otherwise, learn is not only just listening to other people and try to digest that. It's better you go over all the materials and you understand every single part and you deliver that to every single person. And again, don't worry, we're gonna record each class. And after each class, we're gonna post a video to the YouTube channel so you can watch it over there. And if you miss any kind of like classes, don't worry. Again, just click this link right here and go watch the video. If you have any question, again, you can post the question in the Slack channel right here. Data Science YYC Slack channel, Slack.com here. And you're super, super welcome to join the Slack channel and ask any question you want over there. And we are going to email to distribute the course materials and lab handout each week before the class, usually just 1 week before the class, so that you guys have a general picture of what this kind of lecture is going to look like. You don't get a panic, you don't want to actually get a panic when just 1 day before a lecture, we just give you everything. It's really hard to get real prepared for that part. And during the lecture, if you have any questions, don't worry, type your question in the chat box. We are going to check the question every 30 minutes. We're going to check the question every 30 minutes and we'll answer the question you have over there. So don't worry, just type the question over there and we'll try our best to answer all the questions. And I strongly suggest you guys to use the Google Colab to actually do the hands-on coding part. Actually, I shared a link in the chat box as you can see over there. So if you have a Google account, it's totally free. And this is going to be the platform, the main platform we use for the hands-on coding, so that you don't have to download Python. You don't have to actually use your Jupyter notebook. You can just use a web version of the Jupyter notebook to actually run all the codes you have over here. Okay. All right. So I'm going to pause here for a second, see whether there's any questions in the chat box here. Okay, So again, if you have any questions, type in the chat box. I will check that every 30 minutes. Okay. So any questions so far about the ML bootcamp, about myself, or just ML camp? All right, seems like there's no questions so far. Okay, let's keep going. So, oh, one question in the chat box right here. Is this the first time organizing ML bootcamp? That's a good question. We are like, independently, not actually forming, before we actually collaborated with GDG Cloud, Edmonton, we as, Calgary Data Science Academy, we organized about two times the ML bootcamp twice before. So this is more like the third time we are organizing the ML bootcamp. And in addition to that, we also organize the natural language processing bootcamp as well. So, and also some kind of basic Python coding bootcamp as well. So you're welcome to actually click the link here of the Data Science Academy over here to learn more about the programs we are running right here. But this is actually the third time we actually organize this kind of bootcamp right here. Okay. All right. Okay. So let's go into the details of today's lecture. So I actually want to give you guys a general picture of what today's lecture is going to look like. So today's lecture is going to be explanatory data analysis with pandas. So before that, we're gonna, give you guys a general introduction of machine learning. Like, what is machine learning? Why do we actually want to learn machine learning? And how do we learn machine learning? Like, what's the roadmap of machine learning look like? And after that, I'm gonna give you guys a general kind of introduction of the machine learning model structure. So basically, it has a lot of different steps. Data cleaning, that's the first step. And the second step is explanatory data analysis, which usually is called EDA in the interview. So if you are actually having a data science interview, EDA is usually what they call about this part. Plus data visualization, which is the second part of today's lecture, which will be given by Lei Xiao. And the third part and third kind of like a step here is feature engineering. And next part is going to be which model to choose to build. And next part is going to be how do we train a model? How do we actually evaluate a model? And after that, we're going to talk a little bit about how do we actually optimize the model? How do we actually search for the best parameter that fits the model? Then after all the steps, you are ready to actually push the model to the production. Okay, so first part, what is machine learning? So machine learning is defined as the use of algorithm and some kind of math statistics to learn from the data, basically to answer the questions related to the data. To summarize a little bit in a really short sentence, that is, machine learning is to use data to answer the question. Okay, but it actually uses the data in many different ways, with or without a model, or with different kind of model, with advanced model, or with some kind of really basic model over here. Okay, actually machine learning is everywhere in our life. It covers so many different aspects of our life. I mean, think about it. Google search. Every time when you actually open the Google, for example, I can do it right now. So if I search machine, if I only type in a machine and then it comes up, learning, classification, apple, orange. That's my kind of like, search history. But how does, Google learn that? How does it memorize all those kind of history and recommend that to me? Why not is like, why is it's ranking in this way? It's like apple, orange is the first one, classification is the second one, deep learning, NLP is the third one. How do you actually rank that? So this is a part of the machine learning. The recommendation system from Google search is a really good example of machine learning. And also, I suppose most of us actually watch YouTube every day, pretty much, right? So every time when you open the notebook, when you actually open the YouTube, like the home screen, you will have a bunch of video recommendation. But how do they know like those are the videos you are gonna like, right? The recommendation is also part of the machine learning right here. And also many other, kind of like advanced technology, like a product recommendation from Amazon. image recognition, self-driving system, you name it. It's just a lot of those kind of areas utilize huge amount of domain of knowledge from machine learning. So yes, that's pretty much everything about machine learning. Now, the next question we're going to answer is, why machine learning is so important? Why do we want to learn that? I mean, think about it. If you have a bunch of the data, especially if you work in a bank or in the oil industry, you have a bunch of like the data about the storage cost of the oil, the price of the oil. What if you want to predict the price of the oil or predict the storage cost of the oil? What are you going to do? You're going to use the data, but how? That's why we learn machine learning. Machine learning offers a way that actually, helps you to make a prediction, to make classification, to make a recommendation. Okay, I mean, think about one example is like, when you listen to music by Spotify or Apple Music, they actually recommend a lot of songs. So how do we actually recommend the songs? They actually use a lot of your listening history and use that as a backup plans, and actually look up into the frequency of each song you listen to. Then probably gonna recommend the highest, the frequently listened songs over there. So that's an example of how machine learning is actually used and why it's so important. So I just want to show you guys a little bit about the project I worked on previously when I was working in Air Miles company. So I mean, you guys pretty much all have the Air Miles card, like the rewards card you have. So I worked in that company last year in the summer. So basically, we did a project on the customer segmentation. So what we have is we have a bunch of the consumption data from a bunch of different users. So we have, the older users, elderly users, we have the young users, we also have the men and women users. And we know what kind of product you purchase every single day, every single transaction you have. Then what we do here is we use the LD model. We put everything into the LD model. Then we can automatically classify what kind of consumer you are. So basically at the end, for example, we can classify, are you a vegetarian, just like a Popeye, or are you a balanced diet, or are you a junk food eater? So basically, based on the grocery kind of consumption you have, and based on the model we have, we can actually classify different kind of users just like this. So this is the output we have for different users. So as you can see here, we actually have 1, 2, 3, 4, 5, 6 different group of users. By click each kind of like circle right here, I can see what are the most frequent purchase products you have. For example, if I actually click one here, mushroom white is on the top. Carrots mini peeled is second, container, red chili scrape, onions, large celeries. As you can see, all the stuff right here are vegetables. So we actually extrapolate a little bit. We say this row is actually vegetarian. So that's the magic part of the model. So based on just a transaction, just like the name of the product you purchase, we don't need a price, we don't need a quantity. We can extrapolate what kind of consumer you belong to in this kind of group right here. Okay, so I actually show you the power of machine learning. That's why it's so important, because we can use it actually for different purposes over there. So the next part is going to be, how do we learn machine learning? Since we know what machine learning is, how important it is, but how do we actually learn that? So the basic roadmap to machine learning is that machine learning includes two main parts. The first part is called supervised machine learning. The second part is called unsupervised machine learning. So supervised machine learning takes the labeled data. So the key part is that it takes the labeled data and creates a model that I can make predictions given the new data. So what does that mean? That means I give you the X, but I also give you the Y. I told you what my goal is going to be, what my target is going to be. Based on the X I offered, based on the Y I offered, you tell me how you can make the prediction based on the X. Okay, so one kind of task from this supervised machine learning is called regression. I mean, pretty much everyone here knows regression. So regression basically is a prediction on the future. I mean, one example is like can be the predicting the future price just based on the past price movement right here, right? But you have to tell, for example, for this one, suppose X is the past price, Y is a future price. You have to tell the model what the future price is and what the current price or the past price is. Then it can make a prediction or linear prediction on that, right? So the Y here is what I refer to as the labeled data. The label data. So you have to tell the model what the label data is. So usually this type of model have continuous outcome variables over here. Okay. So when it comes to the continuous variable,
Hi, I think I will lose it.
Is the connection stopped for everyone?
I can hear you, but not to Daniel Ma.
Sorry about that part. I hope I didn't actually miss any importance or make any inconvenience over here. And I was a little bit upset because I was kicked out of the. But now I'm back. So anyway, let's keep going. So after the regression, we're going to have another subtask of the supervised machine learning. It's called a classification right here. Okay. So a classification problem is actually a little bit similar to the regression, but it's actually trying to predicting the categorical outcome variables. So it's not like continuous variables. It's like a categorical variable. For example, if I give you 1, 2, 3, 4, 5, 6 different kind of like vegetable, not vegetable, fruits right here, they're either apple or orange. How do you gonna classify that? So it's more like you tell me this is like, let's go through every single one. Is this orange? Is this orange or apple? Is it orange or apple? It's like yes or no question over there. Okay, so that's a classification problem. But both of them gonna take the labeled data. So basically, you are gonna tell the model what this is. Is that orange or apple? Then the model is gonna learn to memorize that. Then actually applies the memory to the new kind of like data set that doesn't really have the labeled data. Okay, so unsupervised machine learning is the second part of the machine learning. So this is when we are dealing with the data that has no label or no categories. So that's a huge difference from supervised machine learning. Basically, you don't tell them what a Y is, what a label is going to be looked at. Like, so you don't tell them, oh, is this apple or orange? You don't tell the model. The model is going to learn the pattern of the data or the structure of the data itself. So that's called unsupervised machine learning. Basically, you don't supervise the model, it learns itself. So in the unsupervised machine learning, it has two different categories. First one is called clustering. Clustering is similar to classification, except again, it doesn't have the labeled data. It doesn't have the labeled data. So basically, it's group-alike data, and data in the group should have similar properties or features to each other. Okay, just like a classification, but it doesn't really have a label here. Another part is called a dimensionality reduction. Dimensionality reduction is actually trying to compress the data by removing, kind of like some random variables which are not important and holding onto the principles ones with, without actually losing the general picture of the data set. For example, let's think about, we try to make a prediction of the oil price. And think about, we have 100 variables to actually make the prediction. We have 100 axes, and we have one variable, which is Y, which is oil price. Are you going to use all the 100 variables over there? It's not. I mean, you can if you have a super powerful computer, but the better way or the smarter way is try to pick up, the most important variables, or try to reduce the dimension of the axes and pick the most important ones and use those most relevant axes to make the prediction. So that's what a dimensionality reduction is about. So for example, suppose we have 3 different variables. We have the 3 dimensions, X, Y, and Z. So dimensionality basically tells you if you want to actually reduce them into a 2-dimensionality, like 2D dimension, that works. Or you can compress that into 1D dimension. So here's like a 3D, or like a 3D dimension matrix. You can think about in that way. Here's like a, 2-dimension matrix right here. That's the column, that's a row, and you can reduce that into a vector. Okay, So basically, that's what dimensionality reduction about. Again, but you don't tell them which variables are important or which variables are the most relevant. It learns the pattern itself. Okay, so that's basically the general picture about the machine learning roadmap. So I'm going to pause here for a second. That's answer the question from the chat box a little bit. Okay.
I think Mon has two very good questions. And also Caroline has one question. So Mon's first question is, what's the difference between machine learning and deep learning? And the second question is, sorry, kind of buried somewhere. The second question is, what other types of learning do we have?
That's actually the question I'm trying to answer in the next part, but I can just bring it right here. So except for those kind of models, those kind of like, roadmaps we have for machine learning, we also have reinforcement learning and deep learning and natural language processing. Okay, so except for those, you also have other learnings, but those are the most like hottest topic or hottest like, AI topics we have currently. So think about reinforcement learning as learn from the mistakes and try to maximize, the goal of the project. I mean, think about the AlphaGo. So AlphaGo is a typical example of reinforcement learning. Basically, it play a chess game with a human, but every single time when he made a mistake, he will memorize the mistake and improve on the mistake, and then do a next step. So basically, every single subsequent steps was based on the previous step. So kind of reinforcement learns every single step from the past mistakes over there. So other learnings, except for that, is deep learning. So deep learning is about utilization of a neural network, just like the human brain. So it's like, try to actually interact with, try to actually use the interaction between different neurons and use a super complicated, like the hidden layers, like on top of each other to do the learning over there. So speaking of the relationship between machine learning and deep learning and reinforcement learning, so you can think about the deep learning falls into the supervised and unsupervised machine learning subsection. So deep learning is more like a subset of machine learning, but in a more advanced way. And reinforcement learning has some kind of interactions with machine learning, but it's not a subset of machine learning. It's more like it utilizes some kind of basic models from machine learning, but it actually make a further big step on top of that. Natural language processing is about the language models, is about the language learning. So it's a totally different kind of like, area, I would say, but it also uses some kind of like models from machine learning. So it has some kind of overlap with machine learning, but it doesn't really, totally overlap with machine learning. I hope that answers, the question from Meng, I guess. So that's our first question. And
yes.
Sing, can you just repeat the next question right here?
I think you solved the second question of Mon, which is like, what other types of learning?
No, my second question, I guess, is what's the difference between machine learning and the Bayesian learning?
Okay, so what's the difference between machine learning and the Bayesian learning? Oh, okay, so you can think about the Bayesian learning is more like a statistical kind of way, or use a statistical model to answer the question, use a probability kind of model to answer the question. But machine learning is more than that. Machine learning actually try to use more than probability. Sometimes it actually use regression, which is not like a probability model. Sometimes they actually use classification. Like for example, later on, you are going to see the random forest model, the decision tree model, which is more like, it's more like, kind of like the loss function learning based model, which is totally different from the probability model. And about for example here, clustering dimensionality reduction is more like, not actually based on the probability. I wouldn't say probability is more like about the loss function. It's actually part of the learning, but it's not like totally how the model is going to learn. But it actually used a lot of different kind of metrics or different kind of like methodology to learn that, more than just use the statistical model here.
But it sounds to me it's like you guys are including a bunch of different methods and algorithm or approach, and you call everything machine learning. And when I ask what's this differences, everything is included in the machine learning.
Yeah, everything like that is included in the machine learning. Bayesian like learning is also
like we are learning the statistics again, and we just call a new name.
No, it's not a statistic. The thing is like it's not about statistic. It's actually about a different kind of thing.
If this is not about statistics, then what's the difference between machine learning and statistics?
So machine learning actually is more about it's actually more about learning and memorize, the training data set. So I mean, for example, if we try to make a classification between, or I can just use this example right here. I mean, if you try to classify different kind of customers just based on the, their kind of transaction, use LD model. Can you do that with a Bayesian, like a Bayesian kind of model you just mentioned over there?
In a very simple sorting way, just like use the statistical tool.
It's not about sorting. It's not about sorting. That's a question. It's not about sorting. So it's about the learning. It's about actually learn from the previous mistake.
It's not about sorting. What is it about? To me,
it's about the classification. I mean, it's about actually rank all those kind of different kind of products based on the frequency or based on the the popularity.
Statistic again.
I don't quite. I mean, we can talk about this later, but I don't really think Bayesian learning is more like I
don't mean the Bayesian learning. I mean when you say you're putting them in different classification based on their frequency. This is a very simple and basic statistical problem, right? So why do we want to call it a machine learning such a fancy name when we already have the tools frequency?
Okay, let me give you an example right here. Okay, decision. Let's do a random forest. So for example, if we try to do a decision tree or a random forest just like this, and we try to classify whether a consumer is, he's gonna pay the loan or he's not gonna pay the loan. How are you gonna use a Bayesian model?
We do not have to use a Bayesian model. You just need to have a model and predict the probability.
Right? How? That's the thing. How?
You have the model. You just need to build a rational model and put all the model in and estimate the model, right? Using MLE or whatever method you like to use.
But what model? That's the thing.
Okay, so that's what we learned from econ. You need to build a model.
But what model?
Here, right?
Right. But what model?
Which makes completely economically sense. Then you can use the data to predict that model, not to estimate the model, not predict. We only call them estimation, not prediction, too.
But what model? That's the first thing. And how do you actually memorize a pattern from the data? That's the second thing.
What do you want to memorize the pattern from the data when you have a model?
Okay, guys, I think because this is a really, really interesting topic, what's the difference between statistical learning and machine learning, and both, like really from really different point of interest, everyone actually was wondering, but because we have a course content to give in for the time frame of 3 hours, I suggest that we take this question offline and continue this discussion in our Slack channel so that Daniel can carry on the course content and everybody is kind of on the same page, because we have some, obviously me has a pretty advanced knowledge about machine learning, but some people probably just like get into the field.
Yeah.
So they might not understand this discussion. So to be fair, let's move this discussion offline, to Slack channel and continue the discussion after the class. And thank you.
Okay. Let's keep going, try to answer the next question here.
Yeah, it's from Caroline. She asked, is it fair to say that dimensionality reduction is inherent to unsupervised learning?
Yes, so like dimensionality reduction is more like most commonly, actually, when we mention that part, we don't actually give them the label. I mean, if you give them the label, you can also do them dimensionality reduction. But in that way, we don't usually call that dimensionality reduction. I mean, if you already know which kind of variables, which subset of variables are very important to you, you can barely use a model to actually select them. You can just select them, kind of model yourself, right? That's the difference between, kind of like knowing the label and without knowing the label. So usually when we do the dimensionality reduction, we don't know which variables are important or which dimension is the most important. So that's the thing why we actually usually just put that into the unsupervised machine learning, because we don't know like what we are looking for. We just want the data tell us, what the most important kind of variables over there. Hope that answers the question.
Yeah, thank you.
Okay. So what about the next question here?
I think it's from Khaled. She or he asks, I assume part of machine learning, at least dimensionality reduction, is to avoid making improper associations, such as correlation versus causality.
So yeah, I mean, if you learn, probably have some kind of background dimensionality reduction. For example, when we talk about one of the examples, the PCA, principal data analysis over there. So the principal component analysis over there. So when you mention that kind of model, usually the way we do that is try to eliminate the correlation between every single variable. So that's not like the main goal of the model. It's more like the side effects or the subset of the goal that comes along with the model. So when you finish the dimensionality reduction, it automatically will have some kind of variables which are not correlated with each other. So it solves a lot of problems. For example, overfitting, or for example, the regularization problem or the multicollinearity problem we call it. So for example, if we have a bunch of variables like, your year of working experience, your age, and your schooling, those three variables are actually correlated with each other. So we try to select the ones with the best kind of like implication. Then we need to actually get rid of all the association with those variables, because association between those variables means you have redundant variables over there. So that's correct, but that's not the goal of dimensionality reduction. And some kind of like dimensionality reduction algorithms don't really have that kind of feature. But I know PCA has that feature. Some other kind of algorithms do have that feature, but not all of them have that feature. Does that answer your question, I guess?
Daniel, we might need to carry on our course because we're gonna have a break in about 45 minutes-ish.
Sure, okay. So we finished like the machine learning introduction here. So next part, I'm gonna give you guys a little bit like guidance or some kind of like, introduction into how actually we do the machine learning. What's the basic steps we're gonna actually do a machine learning, especially when we actually try to solve a task over there. So the first step, of course, is the data collection and cleaning and preparation. So, I mean, we don't really talk about data collection. It's more like, not actually part of the machine learning, but data cleaning and preparation, I mean, try to get rid of the missing values, do a sanity check on the data, right? And try to check the years are the right or price is not negative, things like that. Those are the first step of the machine learning model for sure, because you try to make sure the data is good to actually carry on to do the next step. So after that, we actually come to the second step, which is the first part of the lecture today. It's called Explanatory Data Analysis, EDA. So again, memorize the EDA, memorize the way we call that, because this is commonly actually the term used when you have an interview. People usually just mention EDA, they don't want to actually mention the full name of that. So this is the process of visualizing and analyzing the data to extract the insight from that. So I mean, a lot of like subtasks can be included in this part. For example, can we actually uncover the underlying structure of the data of the data set over here? Can we actually draw a density curve to see the distribution of different kind of like features? Can we actually extract the most important variables? Can we actually detect the outliers? Can we actually detect some kind of anomaly, high or low variables over there? Can we actually have some expectations or underlying assumption on data set and try to test that, right? Or can we actually determine the optimal factor settings from those? Those are actually included explanatory data analysis right here. So today I'm going to give you a really kind of vanilla introduction into the EDA using pandas. How do we actually use pandas to do that? So the next step after that is that we are going to do a feature engineering. So basically, we are going to generate a bunch of different variables that are not included in the data set. So those variables might be the interaction between two variables or three different variables. But the goal here is actually try to use those interaction between different variables to increase the prediction power of machine learning algorithm. I mean, to give you an example, let's think about, let's think about a way, think about a like empirical problem. If we try to test whether there's some discrimination, gender discrimination on the wage, right? So on the left-hand side, for example, let's do a regression on that. So on the left-hand side, we are going to have the wage of different kind of genders. On the right-hand side, we're going to have the gender. But is gender only the variables, or is that variable enough to actually recover the correlation between gender discrimination and a wage? Not really, right? You probably want to add years of experience, or the interaction between the gender and the years of experience, or the gender and the interaction of the gender of the years of schooling. How many years like the women actually received for the education? How many years of the man actually received for the education, right? So on and so forth. So those kind of generation of the new kind of features, new kind of variables, try to use them to actually do the classification and the prediction is actually called feature engineering. I believe in the in the future lectures, a lot of other kind of like course leaders going to cover their part. So next part is model building. So basically, in this step, you are going to think about which model you are going to choose for the prediction or for the goal of the project. So you know what you're looking for. The next part is like what kind of model you're going to use for that. And at the same time, you are going to think what's the pro and cons of the model, and what are parameters of the model and the data needed for that kind of model, right? So those are all the questions you need to think about. Usually, we don't just select one model and we are finished over there. We select a bunch of different models and we do the comparison. And if your boss, tell you to actually use a model to make the prediction, you're going to recommend 3 different models over there, right? And also, you're going to tell them what's the pro and cons of each kind of model, and why do I select that model as a final optimal model over there, right? So those are all the thinkings behind the model building here. Okay. So after that, suppose now you have the best model in your mind. Now it's ready to actually train the model, use the data set you have. Okay, so basically you inject the data set into the model, you actually try to train the parameters or try to find the optimal parameters. Actually, the step 5 and step 6 can be combined into one step, or it can be separated. Let's talk about the first case. It can be combined into one step. So for example, if you're looking for the optimal parameters using the training data set, then those 2 steps are actually the, one step. For example, if we try to do a decision tree, for example, just like the example I had here, a random forest, right? So suppose I try to make a classification of whether a consumer is gonna pay the loan or he's gonna actually, avoid the loan. Just use a different kind of variables right here by going along the trees here. So there are a lot of parameters that you can consider. For example, how many trees, how many kind of subtrees I should take into account. That's a first parameter, that could be. Or how deep should I go for the tree, for each kind of tree here? How many variables I can use for each tree's training here, right? Those are all the parameters that you need to think about when you actually train the model for this kind of model here. So if you inject the data set into the model and do a parameter search, it will actually give you the optimal parameter. And with that optimal parameter, that model is the optimal model with the training data set, okay? But in the case 2, sometimes you need to separate the 2 steps. Why? For example, you receive the data set from your boss monthly, and you train the data, use the last month's data set, right? Now you have the new data set. Are you going to use the old model, or are you going to use the new model, right? So if you want to use a new model, you're going to retrain the model. So in that way, you are going to redo the optimal or the parameter searching, or is actually called a hyperparameter tuning, right? So in that way, it's 2 separate steps. So you already finished that step, you just need to do another round of parameter search. Okay, so it's about a retraining or not. That's actually your decision. I believe in the future, again, the course leader will give you more details on this part. So after that, you're going to do evaluation. So suppose you have the optimal model here. And with the optimal model, you will have the different kind of metrics matter that. For example, accuracy. How accurate your model prediction is to the real kind of label you have. For example, you try to predict whether it's orange or apple, right? So for each kind of data points over there, you have the prediction, and you're going to compare the real label and your prediction, how close they are, right? And also on many different kind of metrics over there, precision, recall, I mean, you name it. There's a lot of different kind of like metrics over there, which will be introduced later for the classification. I believe is like starting next week for the second lecture over there. Okay, so now I'm gonna skip everything. I'm gonna actually just focus on the second step, like the EDA here. Try to focus on this step for today's lecture right here. So EDA with Pandas. Okay, so Pandas is one of the most important library you absolutely have to use for data science. If you go to a conference, if you actually have the interview, people will ask you, do you know Pandas? If you say no, I think you're in huge trouble. It's going to be a disaster over there. So Pandas is definitely one of the the basic kind of library you have to use for data analysis over here. Okay, so data scientists often work with different kind of formats of data sets, like it can be CSV file, TSV file, or Excel file. But Pandas make it really convenient to load, process, and analyze those kind of data to make it into like a SQL-like queries or SQL-like tables. So in conjunction, or try to collaborate that with different kind of other kind of like data visualization tools, Seaborn and Matplotlib library, you can actually have a lot of different functions to explore or to do the data analysis just with the Pandas. Okay, so the main data structure in Pandas are actually implemented with a series and data frame. So basically, memorize those two. You have two different data form in Pandas. One is series, one is data frame. So the former, the series, is one-dimensional index array of the fixed data type. So it's just one dimension. You can think about that as one vector, as a vector. And the data frame is like two-dimension data structure. It's more like a table. It's like it has more than one row, more than one column. Think about that as a rectangular. Okay, but the series is just like a one column over there, just like a vector. So the second one is more like a two-dimension data structure, a table. So each column will usually contain the data of the same type. And you can think about that as a dictionary of the series instance. Basically, it's a bunch of the series. It's a bunch of series getting connected by each other. That forms the data form right here. So it's really great for representing the real data. And we have some terms right here. So try to memorize those as well. So the rows correspond to instance. Okay. So usually we don't call that rows. We call that instance. And the columns, we call that feature of the instance. We call that feature. So for each column represented by one variable, but we don't call that variable. Most of the time, we call the features. Each row is a one data point, and we call that instance. Okay, row, instance, column, feature. Okay. So another kind of library along with Pandas, we often actually use many, quite common. It's called NumPy. NumPy is a package. It's also the basic package in Python. It's a library that actually provides a multi-dimensionality array object. So basically, it actually uses a lot of statistical models. It was based on a lot of statistical models. Try to do the matrix multiplication, or the matrix addition, or the transpose of the matrix, so on and so forth. So it includes a lot of like different kind of mathematical, logical shape manipulation and sorting, selecting, those kind of functions here. So this is also one of the most important kind of library we are going to use in the future. Okay, so today we're going to use those two libraries, but mainly Pandas, to show you how to do a data analysis right here. Okay, so in Python, or when you actually run the code in the Python, if you want to use a library, you have to use import, then the library name, and import as library name again. So for example, if I just use Pandas, I can just import Pandas. But sometimes we don't want to really use that long name. We can use S to actually represent as a really short kind of like a name library here. Okay, so I import pandas as a PD, import NumPy as NP here. Okay, so when you try to use the pandas like, you know, kind of like a function, you can just use a pandas dot and step function belongs to panda. For example, if I just wanted to display the precision of, you know, or the decimals of each kind of like, you know, kind of like data point over here, I just want to actually run it with 2 digits. I can use the stat option and tell the system, I just want to use the display precision, and I just want to run that with the 2 decimals over there. Okay, so that's one way to actually stat the basic statting of how the data set looks like. So here comes a command why I actually recommend using Google Colab. So actually, let's run this. Import that, import this, and just git clone. So this is about cloning everything from a specific repository of GitHub. You can do that with the Jupyter Notebook, but it's easier to do that with Google Colab. So why do we do that? Because in that way, you will have everything from the folder. For example, now it's telling us like we are cloning into ML course AI, and now it's trying to cloning every single data set, every single notebook from these repositories. In that way, you don't have to upload the data set yourself. You don't have to upload the picture yourself. You can just borrow them from a specific repository here. Oh, it tells us it's almost finished over here. Okay. So let's wait for a second. See, now everything has been imported. So if I just open, you know, the file kind of path, like, you know, this kind of like clicks this one here, and you can see there's the ML course AI folder. If you click that, everything is right here. The data, right? The image is right here. Okay. So what you can do is you just use, you know, this mark right here, and along with that, just use git clone, then just put the address of the Git repository, then you can clone everything from there using Google Colab over there. Okay, so this is a really convenient way to do, you know, the data, or, you know, can actually run the data set from somewhere else. Okay, so now I'll actually use the churn rate of the telecom operator client's data set to tell you how we actually use this to do data analysis with the pandas here. Okay, so this data set is about the churn rate of the telecom operator clients right here. First of all, I'm gonna actually read the data set. So the data set is located here. So click data, and it's called a telecom churn here. So telecom churn here is this data set here. So what you need to do is just like copy the path and put it right here. And before that, remember, we're gonna read the data set. So you need to specify what kind of form of data set you wanna read. And for this one is a CSV file. So we're gonna use PD, which is pandas, read CSV. So this is a function that tells you to read a CSV file here and put those in the citation mark. It can be single citation, can be double citation, it doesn't matter. And that will give you the data set right here. And this is just, so this command comes with a lot of different kind of like, you know, arguments over there. So one of the arguments is the header. You can tell the system which row you want to use that as header. So for Python, the index start from 0. It doesn't start from 1, okay? The index start from 0. So the 0 column is actually the first column here. So if I put 0 here, it's going to tell the system the first column, the first kind of row here is going to be used as the name of the variables right here. So after that, we can just look at this like a snapshot of the data set, use the function df the head, because I already named the data set as df. So if I use df.head, I can actually look at the first 5 row of all the data set. So let's run this. So now you have all the variables right here. Start from the date states here, account length, area code, so on and so forth. Many different variables right here. Okay, so if you don't actually add this, that works, but it's gonna give you a lot of different kind of like columns over here. So If you don't want to have all the general picture on everything, you can just use the head function. It will just give you the first 5 kind of rows here. Okay. So again, each row is an instance and each column is a feature. Okay. Now we can actually look at the data dimensionality. We want to know how many rows and how many columns we have for this data set. So in that way, you can use df.shape. Okay. So if you click that, we know that we have 3,333 rows and 20 features. So the second one tells you how many columns you have, and the first one tells you how many data points you have. Okay, so number of the rows, number of the columns. Okay, the next one could be you want to check the name of the variables, the features. What if I just want to know what kind of features I have? So you can use df.columns here. And it will just give you a list of all the names of the variables right here, starting from the first one to the last one. Okay, so that you know, oh, those are the features I have, 20 features in total. Okay, again, start from the first one. The index for state is 0. It's not 1. Okay, so 0, 1, 2, 3, 4, so on and so forth. Okay, so what if I just want to know the data sets type? What if I just want to know each feature's type? I can do that as well. Just use df.dtypes. dtypes, a short for data types right here. It will just give you the type of every single feature here. Start from the first one. State is object. Object basically is more like, you can think about it as a string. It's a string variable. It's just a text variable. Okay. So integer is an integer variable with 64 digit digit right here. And object is a 64 bytes right here. Objects again is a text, and float is more like is a number but with decimals. Is 64 kind of bytes here. So BOOL both here is a condition variable. Basically, it tells you it's yes or no, 1 or 2. Okay, it's a condition variable right here. You can also check the variable's type by using info, like an info kind of function here. Okay, but it gives you more than that. So if you use info, but don't forget about brackets right here because it's a function. Okay, so for this one, you don't really have the brackets right here. So that's the difference. For dtype, don't use the brackets because it doesn't really have any arguments. It's just a single function, no arguments. By arguments, I mean this one here. Okay, so inside a function, you could have a lot of arguments. You can specify what the header is for read.cs here, but for this one, it doesn't really come with any arguments. So you can just like use that. But if you have arguments, but you don't want to specify the arguments right here, you just use empty brackets for this one here. So if you do that, it's gonna give you all the columns. See, start from 0, ends with 19, and it's gonna tell you how many non-null counts of the data points you have. And it's going to tell you the, all the types of the variables right here. Okay. So again, those 3 are and objects are the data type of the 4 of our features. Okay. So I already specified what each feature is, so I won't repeat in that way. Again, next part is change the data type. For example, if you think a data type, like a features doesn't really comes with the right data type, how do we change that? You can use as type. You can use as type function here. Okay. So for example, if I just want to change the churn rate or the churn variable or churn feature into an integer, for example, the churn, I think it should be the last one right here. Let's go back to here. See, the churn here is force. Is actually object or actually belong on variables here. It's like either force or true here. So what if I just want to change that into an integer? So what you need to do here is just specify the variables here. So usually the way we specify the variable is we use square brackets, then we put the variable name inside a single quotation or double quotation. That means we refer to a specific column, specific feature, churn feature, and we actually replace this kind of feature with a new type, use as type function, and put the type of the the new type you want to actually change that into. I want to change that into an integer with 64 bytes. So I put int64. So now let's look at this. So now if you actually use a D type to refer to the specific, kind of column here, it's going to tell you, oh, it's actually integer for the 64. But previously, it's BOL. It's actually balloon. Okay. So again, to actually simply summarize the data set, we also have some other functions. One of the functions is called describe. Okay. So describe methodology or function shows the basic statistical characteristics of each numerical feature. Okay, it only applies to numerical feature, not non-numerical feature. What I mean here is like only float integer, not object, or not balloon here. Okay, only those kind of numerical features. So and it's gonna tell you a lot of different kind of like different statistical here. So if you do df describe. Again, it's a function. I don't want to specify any arguments. Then I just run this. It's going to give you, see, that's a numerical variable. Numerical variable is going to tell you the count, the mean, the standard deviation, the quantile, the max, so on and so forth. But if you look at into all the variables, it doesn't give you any summary on state. Why? It doesn't actually apply to state because it's not numerical. But the count length here is numerical. Okay, so describe only apply to numerical features. Okay, keep that in mind. What if you just want to, have a general summary on the non-numerical features? We can do that as well, fortunately. So in order to actually see the statistics on non-numerical features, we have to use describe as well. But now we can include some kind of arguments right here. So the arguments you include is called include. Equals that. So include gives you an option to include what type of the variables you want to do the describe function. Okay, so previously, if you don't put the include right here, it just gives you the numerical value. But if you use the include like this one here, include kind of like argument here, use a list to tell the system I want to do a summary on balloon data set or type of the variable, object type of the variable. So if we run that, it's going to give you all those state, international plan, voicemail plan, which are not numerical feature at all. But it only gives you the count, the unique numbers, the most frequent, kind of like values of that kind of feature and the frequency of the feature. Okay. It doesn't really give you any, those two, like a mean standard deviation, because it's not numerical feature. Okay. So next part, let's talk about the value count right here for the categorical data set. So for categorical and balloon data set or all features, we can use the value count methodology to look at distribution of that specific variables. So for categorical and balloon kind of features, we can use value count function to look at distribution of that specific feature. For example, we already know that churn is kind of like the categorical features, right? We replace with integer values. Integer is 0 and 1 here. So we can do a value accounts here. So if we apply the specific column and we do a value accounts right here, it's going to tell me how many values are there for 0, how many values are there for 1, how many people are going to churn, 483, how many people are not going to churn or loyal to the plan, 2,850. Okay, so you can also normalize, all those numbers. For example, you just want to look at a percentage. That's okay. So use normalize equal to true as the argument here inside the brackets. It's going to give you the percentage. 86% of the people do not actually leave the plan. 14% of the people are actually going to leave the plan right here. Okay, so let's pause for a sec here and try to answer some of the questions in the chat box. I'm going to start from the bottom one here. So the churn. So as type, what does it turn back? I was expecting 0 and 1. I guess you look into the wrong kind of like table. So for this one, it's not 0 and 1 here, because this is a summary table, it's describe table. But after this, suppose let's do df, trying to look at after this, what df turn is going to look like. See, it gives you 0 and 1s. Okay, but this one's not like a df turn. This is describe. It describe how many zeros, what's the meaning of zeros, meaning of 1, so on and so forth. Okay, so don't actually look into the wrong table.
Thank you.
Okay, so 2A. Okay. So don't write in the notebook, use a link over here. Use the notebook I downloaded, or actually the IPyLab file actually sent over. Because this one is actually belong to my kind of personal drive over here, so you cannot actually run that. So what I suggest is search Google Colab, then open that, upload the notebook I sent in the chat box, then open in that way. Okay. Okay, I think that's all the questions. Series type is series type of data used outside data frames in other library Python? No, series and data frames all used in the same kind of library. For example, let's ask a question. What's df turn? Is that a series or data frame? You can type your question in the chat box. df turn, is that a series or data frame? Yes, Connor just answered the question. It's a series. So that's a series. What if, let's do this, I don't know, area code. Now, same question. What is this? Series or data frame? Data frame. Connor answered that question again. So if it's more than one column, you have 2 dimensions. So it's not series anymore, it's data frame. So if you check that, it's going to give you a data frame. Okay. Okay. What are the questions we have here? Okay, seems like, what about list? Yes, list is actually data structure in Python. I didn't cover that here because I don't really want to spend too much time on that part, but this is called a list. Okay, square brackets inside a bunch of different kind of values, that's called a list right here. So if you want to use more than one column, you have to put the list into another bracket here. So basically, this is a list here. So you tell the system, I want 2 variables here, but this is a list inside another list. Okay, list inside a list. So that's how we actually refer to more than one columns over there. So if you want to know more about this structure, I think I have, yes, I have like a link right here. So on the top, more on this structure of Python here. So if you click that, it's going to give you more information on what's the list, what's the dictionary, what's the tuple, what's the stat, for example, what's the tuple, what's the sequences, so on and so forth. So if you want to have more information on that, just go into that link and try to check more details over there. I won't actually cover too much on that part. Okay. Nice question. That's really nice question, you guys over there. Okay, now let's jump to the sorting part. So, I mean, most of the part we want to sort, a specific columns where sort all the values in the data set, right? You don't want to actually look into the really messy data set. Don't know it's ascending or descending. So we can do that as well. So since we have the data frame, we can use df sort underscore values, and inside you can use a by function to tell the data frame which variable you want to sort the data frame by. Okay, so for example, I just want to sort the data frame for the total date charge here, and ascending is another kind of like a kind of argument here. If you want to actually sort all the values descending, not ascending, you have to specify ascending equal to false. But if you don't put that argument here, it's going to rank everything ascendingly. Okay, so if I do that, sort the value here by total date charge, and then let's look at the data set here. Where's the total date charge? Yes, see the top ones, the 59, 58, 57, so on and so forth. So basically sort everything according to this one. But that could be another question. What if I just want to sort based on multiple columns, not just one feature? Again, use the list here. That's where list come in effect. Again, we use by. For example, if you want to use a 2-column, just type churn. For example, just doing churn and total day chart. You can do that as well. So just use the list here. It will rank those two by those two. For example, total day chart is still 53 is the top one, C, 52, 52. And if you look into the chart here, because I want a standing for the chart and descending for the total day charge, so the chart start with 0. Okay. Like I said, you can also decide which one's ascending, which one's a descending. Just type ascending and give a bunch of the true, false here. True correspond to chart, false correspond to total day charge here. Okay. So that's basically how you do with the sort values, how you actually sort the data set here. Back to the question here. Yeah, we'll have a break really soon. So just keep going here. Okay, so next part is about the index and retrieving a data set. So I'm gonna go through several questions, try to actually tell you how to actually do, how the index can be used right here. For example, if we try to answer this question, what is the proportion of the chart users in our data frame? What's the proportion of the chart users in our data frame? So basically, there's only one variable we can use, right? What's the proportion of the chart user in our data frame? One way to do that is you can specify how many people are churned, right? And then you divide that by the total number of the people, right? That's the logic right here. But how do we know how many people churn? Remember, we have a value accounts right here. So again, if I just do this one here, it's gonna give me 0, 2,850, and 1 is 483 here, right? So what if I just want those number, 483? How do I do that? Just specify the index for that. This is the index. The index for that value is 1. So if I just put 1 here, 483. It gives you a number of the people who churn. And now, what if I just want to know the total number of the people here? Again, we can use a shape function. So if I just use a shape function, it's gonna tell me, for this one, it's gonna tell me, oh, for that like a feature, we have 3,333 values. But if I just type 0 here, which refers to the first value, it's gonna give you the subsequent number. Okay, so what do? Use the first value divided by the second value. That's the number you have. That's a proportion of the churn. Okay, or since we only have 0 and 1s, right? You can just use mean, right? You can just use the mean function here. And fill not here basically means if there's any missing value in that feature, I'm gonna fill that with 0. Okay, but in this way, we don't really need that because we don't really have any missing values here. So if you do this, it's gonna give you the same value here. Only for this case, because we only have 0 and 1 values for this variable here. Okay. So next question, what are the average values of the numerical features for churned user? What is the average value of all the numerical features for the churn value? So in that way, we have to extract all the churn user, right? How do we do that? So we do a condition syntax to actually extract all the churn users. So basically, we do this. So we specify the churn features, and we do a double equal here, and make that equal 1. Basically tells the system, I want all the users with churn variable equal to 1. And use another bracket outside, use a df. Basically, I put a condition into a list. Then I use a mean function. So if I don't do the mean function here, for example, just show don't do the mean function. Those are all the users, the churn users. Okay, if I do a mean function here, it's going to give you all the values of the numerical, mean values of the numerical features. Okay. Excuse me. Next question, how much time do churn users spend on the phone during daytime? How much on average churn users spend on the phone during daytime? So first keyword average, that means basically we use a mean function, right? And churn user, first condition. Second condition, during daytime. So basically we have two conditions. First one, we have to make sure to extract all the churn user. Second one, we have to use the total day minutes or the daytime calls, right? So what can we do? That's specify all the users who are going to churn, and then we specify the column inside that data set. Okay, and we use the mean function. Here we go. Okay, here we go. Or, which we'll talk about later, you can use the apply function here as well. So use apply, and inside just type mean in the single quotation here. It's going to give you the same result. Apply function basically apply a different kind, like a sort of different function to actually do this same analysis right here. Okay. So next question, what's the maximum length of international calls among loyal users who do not have an international plan? It's a long question. So let's break into several different parts. Maximum length, right? That basically means we have to use a max function. That's the first part. International calls basically means we have to extract all the international callers, right? First condition. Second condition, loyal users turn equal to 0, right? Two conditions. Now, who do not have an international plan? Third condition, right? Third condition right here. So again, we have to do loyal users without the international plan, but we want to look into the length of the international calls and extract the maximum value of that. Okay, so how do we do? We have two conditions here. So if you have more than one condition, make sure use a brackets right here. Okay, so we do df square brackets, then brackets, first condition, turn equal to 0. Second condition, international plan is no. Okay, so use a bracket for each condition, and between them, use and, because you want to extract all the loyal users without an international plan. Okay, and we want to look into the maximum total international minutes. So we specify that column and we use a max function. And here we go. Okay, or again, you can use the apply function, type max. Here we go. Okay, so break the question into small parts and try to answer all the questions step by step. Okay, so last part about, I think this is the last part about index right here. So what if I just want to find a specific column and specific rows, right? That could be one of the concerns we have. What if I just want a specific feature, for example, the voicemail plan, and I just want to look into the last row of that kind of feature. Can I do that? For sure, you can do that. So there are two functions you can use right here, log function and ilog function. The log method is used for indexing by name. Okay, so memorize that. Log is for indexing by name. ilog is indexing by number. Indexing by number. So what I mean by that is, for example, if I just want the first three row here, or sorry, the first 4 row, and I want the feature from state to area code. I just want this part. I just want this small part here, this part. So how can I do that? df use the log function, because you are using the name of the feature, so you have to use the log function here. So first one, specify the span of the row. Okay, so the row start from number 0, and I just want to cut it off at third. So I use 0, then that, comma, not comma actually, use that and 3 here. Okay, that basically tells the system I want the row 0 to row 3 here. Okay, and I want a column state to area code. So state, column length, and area code here. Okay, so if you do that, it's going to give you this small part. Okay, again, we can do the same kind of thing using ilog, but now ilog only goes with indexing by number. Indexing by number. Okay, so how do we actually transfer that into a number? So think about this as index. So state is 0, 1, 2, 3, so on and so forth. So do the same thing. For example, I just want the first 3 sorry, column here. So use ilog. Again, the index for the row doesn't change because the row index is already, 0 to 0, 1, 2, 3. It's already a number. But I just want to change the name of the column into an index. from 0 to 2 here. So if I do that, it's going to give me, sorry, if I do that, it's going to give me the same, not the same, it's actually going to be 4 right here. Yes, it's going to give me the same kind of like outcome from the first one here. Okay, it's going to give me that from the first one. So what I want to say here, so is that the difference between log and ilog is that you're going to use a name here for log, but you're going to use a like number for ilog. Another difference is for the log, it's going to include every single row from 0, including the last one, the third one. But for the ilog, it's not going to include the last one or the last kind of like column here. Okay, last column here. But for this one, it's going to include the last column and last row for log. But for ilog, it's not going to do that. Okay, so in that case, you have to specify I want it from 0 to 4, but it's not going to extract 4. It's going to extract 0, 1, 2, 3. Okay, so that's a difference. Again, you can actually extract specific rows, specific columns using ilog. Use a list here. For example, I want a first, third, and fifth row, first, third, and fifth column. Give me first, third, and fifth, first, third, and fifth. Okay. What if I just want a last row? What if I just want to use actually the last line of the data frame? We can use either this one, df. We don't use log or ilog here, so that's a special case. We just use a df, and inside the brackets, you can either do this one or -1, that. Okay, so if I do this, that's the last row here. Okay. How much time do I have, Xinli, for the lecture here?
So the latest that we can go for the first section course is 2:50, and I think we need a 10 minutes break before that. So I said 2:35, but
So
probably
5
I
more
can go
minutes?
for
Yeah.
2:40. I see you almost like have a little bit chunk to finish. Is that 10 minutes-ish? Okay.
Sure,
I hope that's okay for everybody.
There.
Sounds great. So we're breaking at 2:40.
Okay, sorry, just try to answer this question really quickly. After doing the df sort and df fill so the question is, after doing the df sort and df fill in your EDA, is your df object now different from the original df read from CSV? Really good question. So when you do this, when you do all this kind of manipulations here, for example, df sort, right? Or this one here. So suppose I try to do a df you don't really attribute this to any specific column. You don't really, change the value here. You just do a manipulation. So, but this is going to be different if I do this. So the original data set doesn't change, but it's going to change if I do this. That's going to change the original data set. Okay, so you don't actually attribute any value to original data set subcomponents or the original data set. You don't really change the data set yet because you don't actually do the equal thing. So basically, you are just doing a separate task which doesn't affect the original data set. To answer, I think that's Jimmy and Jimmy's question here. Okay. I wonder whether, another question is from Wee. I wonder whether DF query is more efficient than DF quantitation to make queries. I mean, you can actually use this. So there are different ways to use a column. For example, you can use this, for example, DF, not this one. You can do this for to actually extract a specific column as well. So if I did do that, it's gonna work as well, but I don't know. I don't really get used to use this way to actually extract a specific query. So most of the time, I just use that one. And for the conditions, usually what I do is not use a query again. It's actually more like put the conditions into the brackets. So at least that's what I use when I was working. I don't actually use a query too much. I hope that answers your question here. But of course you can do that. But in order to make everything more straightforward, I think inside the square brackets is gonna be more kind of like in terms of visualization, it's gonna tell you what the conditions It's going to be more straightforward and user query over there. Okay, so try to wrap up this here. Okay, so applying, next part is applying function to cells, columns, and rows. Okay, so that basically actually goes to the function, which is apply function, and also some kind of other function like a map function and replace function. So let's talk about apply function. So apply function is a function that can apply specific function you define or defined by some other libraries to the specific data set you have. So apply can be used for both data frame and data series. Okay, some of the functions can only use it for data frame or only data series, but this one can use it for both. Okay, so it's absolutely the first choice or the safe choice you're going to have. For example, what if I just want to actually find the maximum value of all the numerical features? You can do df.apply. Then inside, you can actually use the np.max. So this is a function that from the NumPy library is going to extract the maximum values from all the numerical feature. So if you do that, here we go. I mean, this is a redundant way to do the max. You can just specify the max directly, but I just want to show you how to do the simple apply function. So this is a already well-defined function by some other library. You can use like more than NumPy. You can use I don't know, like other kind of libraries over there to do this as well. Another way to do this is actually apply your self-defined function to do apply. For example, suppose I want to extract all the states, start with a W. I don't think there's any library going to do that for you, right? So you can do it by your own. You can actually define your own kind of function here. So what do we do here is I'm gonna, first of all, I'm gonna actually cite this kind of like column state here. So use apply here. And inside apply, I'm going to use a self-defined function. This is a really easy way to do a self-defined function. Usually, if you have one line of the code, you can use this one, a really short way. So basically, lambda x basically tells you I'm going to define function on the x. Okay, and what I'm going to do is I'm going to find all the x that in the first position. So in the first position, because in the first position or in the index 0 is going to refer to the first letter of the state, right? You only have W here. So 0 basically means the first letter. To the first letter that equals to W here. Okay, lambda function on x, and I want all the x's with the first letter equal to W here. So, and this is part of the apply. So now I extract all state with, actually started with a W, but I want all the columns and not only the state column. So what should I do? df use another bracket outside this, okay? And let's look at how that works. See, all the states started with W are here, okay? With W here. So that's how you can do your own self-defined function here, okay? Or which I'll talk about later. So another kind of way to do the apply function is the map function. A map function, they actually pretty much have the same kind of similar kind of property, but it can be only used for series. Okay, map can only be used for series, but apply can use it for both. For example, I want to replace the international plan, which have the yes value to true, no value to false. Okay, so how can I do that? First, specify a dictionary. So a dictionary is a data structure that maps the original value or one value to another value. Okay, so this one is called a key. We usually call that key. This one is called the value. So we map the key to the feature. Basically, those two are linked together. Okay. So for example, I just want to replace yes with true and no with false. I just use yes and that, true, no, and false. Okay. So I first define that. I call it a D, give it a name. Now, what I do here is this is actually change the original data set. That's what I mean by change the original data set. You replace the international plan by using df international plan map, then put D inside. And let's look at how that works. See, false, true. That's the international plan. Okay, but it only works for series, not the data frame. Okay, So another way to do this is you can define your function, a really complicated function, like use a DEF. Define the function name, and the argument of the function. So I'm going to define function TF. It's a function about x. If x is yes, I'm going to return true. Otherwise, I'm going to return false. Okay, it's actually basically the same function as this one here. Okay, so if I do that, I can just use the international plan map TF. It's going to give me the same value. You can also put this into an apply function. It will give you the same result as well. You can try that. Okay, so those DEF can also use it for apply. Okay, for apply as well. So next part is replace. So fortunately, replace is actually another function, which is a subset of apply function. So the main goal of that is try to replace a value overall, replace the original value. So it can be used for both data frame and series. Okay, so replace both data frame and series, apply both data frame and series, but map only for series. Okay, that's a difference. So again, let's do the same. Let's replace the yes and no with true or false for a voicemail plan. So what I do here is, this voicemail plan replace and place D here. That's gonna give me, so previously is yes and no, right? Here. So after I do this, true or false. True or false. Okay. The last part, I think this is the last, almost the last part right here. Okay, so grouping. So what if you just want to group a specific, kind of like columns, and you want to actually apply a bunch of statistical function on top of that. For example, I want to see to group this kind of like a data set by those 3 variables right here. And I want to see the percentile of, those 3 variables right here. Sorry, I want to group this data set by charn user or not charn user. I want to see the percentile of that group, the result on these 3 variables. How do I do that, right? So you can use a group by function. This is really common user function over there. So the syntax works in this way. df group by, inside, you tells the system which column or columns. If it's a column, you just use a single variables right here. So if it's more than one single variable, you just put a multiple column name here. Okay. So inside it tells the system which column you want to group by. And second argument is which column you want to show, or which column you want to show after the group by. Okay. Next part is what kind of statistical function you want to apply to those grouped by columns here. Okay. For example, if we try to group by the data set by the churn rate, by whether churn or not, I just want to see the percentile, the quantile of the total day minutes, total evening minutes, and total night minutes. How do I do that? df group by, inside, I put churn, because I want to group by churn, right? And I have this column to show, right? So I name it as a list here. So I put this inside another list, column to show. This is the column I try to show. And I want a quantile. So how do I do that? Use the describe function inside, use the percentile equals to empty list here. Empty list here. So basically this tells the function, tells the system, I want a quantile. So if we do that, total day minutes, total evening minutes, churn 0 and 1 is going to tell you the count, the mean standard deviation, so on and so forth. Okay. Okay, I guess it's time to take a break right here. And after 10 minutes break, we'll just get back and try to finish the last part, transformation with the data frame. Okay. Thank you guys. See you guys in 10 minutes. Left over. Okay, I'm going to answer the question first, really quick questions here. Let me just look at the chat box. So actually, there's a really good question like Jimmy put over here. Like when we do a list sort, there are 2 ways to store the list. Like for example, suppose we have list 13, 12, and 1 here. You can either do a sort, or you can either do this way, or you can do it this way, sorted LS, right? So the difference between the 2 is like a sort. This function is going to change the original list. So if we do the sort, it's going to give us, if we print the original list, it's going to be 1, 12, 13. but sorted doesn't really change the original list here. And that's what Pandas works, how Pandas works. Because Pandas is designing in a way that doesn't actually manipulate the original data set in case you still want to use the original data set. So it doesn't make changes on the original data set. Instead, it will actually make a temporary copy of the data set, then change the temporary copy. But it doesn't really affect the original data set. Okay, so that's the difference here. I hope that answered your question for like Jimmy's question. That's a really great question, by the way. So another question is from Roy. Any difference between Jupyter Notebook and Colab? So those two works pretty much the same way. It works pretty much the same way, except sometimes there's a lot of difference actually, but it's not a huge difference. Except that for Google Colab, you can copy the Git repository from someone else directly and quickly. Not like a Jupyter Notebook, you have to download the dataset and actually you can do the Git clone as well, but it's going to be slower. It's going to use a local memory over there. But for Google Colab, if your local memory has been fulfilled, it can use like a cloud from Google to actually fulfill the kind of like the task you have over there. It's going to be quicker. And other than that, the markdown, how I roll the notebook, how I run the codes, is pretty much the same. So and also for the Google Colab, it has most of the library already installed, so you don't have to install the library yourself. But for the Jupyter Notebook, sometimes you have to install the library yourself, and you could install the wrong version sometimes, right? But for this one, everybody using the same version. They try to keep everyone on the same page over there. Okay. So that's this part. So let's keep going from where we left over there. Okay. So actually, this is related to Jimmy's question. So for example, kind of actually. So I think we're left right here. Yes. So we can do the grow by function, like grow by churn, and we want to see the quantile on those kind of variables right here, right? So grow by churn, then column to show. Another way to do this is you can apply different functions. So the best way, the beauty of the pandas is you can use the chain of the functions. You can concate every single function after another function. For example, after I use a grow by function, what if I don't want to actually see the quantile? What if I just want to see the statistic, like in the mean, max, and also standard deviation, so on and so forth? I can use another function, which is called the aggregation function. Okay, so short for AGG. So inside, you just need to put the list of the statistics you want to see. For example, I want to see the mean, max, mean, standard deviation, right, and median. So if I do this, it's going to give you not 50%. It's going to give you exactly what I want here. So in that way, you can customize your own kind of function somehow using the already defined function in this way here, do the grow by. Okay. So the last part, summary tables. For example, sometimes we want to have a really not general, detailed summary of the some kind of features right here. For example, I want to summarize over churn and the international plan. I want to see how many people who are churn but also have an international plan. How many people who are not churn with the international plan, so on and so forth, right? I want to see the interaction between those two variables. How do I do that? If you only have two variables, you can actually do a cross tab. For example, pandas cross tab, and then inside put the two features you want to do the summary for a table. For example, I want to do churn. I also want to do international plan. Okay, so there's also some kind of arguments you could put over here. For example, if I put a margin equal to 2, it's going to give you the total number for specific summary. Okay, what I mean by that, let's do example here. Okay, if I do this, what I have is, for the churn, it's going to be 0 and 1. It's going to tell us 0 and 1 here. And for the international plan, it's going to be 4 and 2. Now I know how many people are not churn, but they don't have an international plan. How many people are churn and they have an international plan, so on and so forth, right? The interaction between the two variables. And if you put the margin equal to 2 here, it's going to give you all the values for this specific value. It's going to give you the summation here. So that's a margin, how the margin works. But that's a really tedious way. What if I just want to actually see the percentage? Again, just like what we did before, put another argument here, normalize. Normalize equal to true. Again, margin equal to true doesn't change. Now, we know that 80% of the people are not going to actually leave the plan, but they don't have an international plan, right? Not like an absolute value here. It's more like a percentage in this way. So that's one way to do the summarization. So with 2 features, what if we have more than 2 features? What if we have like 20, 30 features? Don't worry, we can handle that kind of case as well. So we can use pivot table. I mean, for those who are pretty familiar with Excel, you know what a pivot table, right? So pivot table is more like an expanded version of this, right? So for pivot table, we have several parameters or arguments here. The first one is the values. The value is actually a list of variable to calculate the statistic for. So you have to specify the value, which values or which kind of columns you want to actually calculate the statistic for, right? Second one is the index. The index is a list of the variables to group the data by. Because when you do a pivot table, you want to see for a specific value how many values over there. You want to actually group by specific values over there. And the aggregate function tells you the statistic you need to calculate for a group, like for example, the mean, sum, so on and so forth, right? So let's do an example. Let's look at the average number of the day, evening, and night calls by area code. Okay, so the task is calculate the average number of the day, evening, and night calls by area code. Okay, how do we do that? First of all, we know that we want the day, evening, night calls. So we put those 3 columns into column to show. Okay, that's the column we try to calculate statistic on, right? That's values. And index to show is area code because we try to group by index, by area code, right? So we do df pivot underscore table, then we put the column to show the value here at the first arguments. Second, index to show here as a second argument where we group by. And the last one is the aggregate function, AGG, F, U, and C. What kind of function we want to do? Because we want to do the average number, right? So I can just put aggregate function equal to numpy dot mean here. I want the margin equal to 2. And if there's any empty value or missing value, I want to fill that with 0. So if we do that, here we go. By all the area code, I know what's the mean. For example, for 408, the average day call minutes is 11. Average eve call is 99, so on and so forth, right? So that's basically how pivot table works in that way. So you can do in this way, or another way to do this is just use the pandas directly. You can use a df pivot table, refers to the specific data set, but you can also use the pandas to refer to a different data set, right? So if I do that, I can do pandas pivot table, tells the pivot table which data set you want to use, then copy everything here to here. Column to show, index to show, aggregate function. Okay, so in that way, it works pretty much the same. I just don't add margins, so you don't have the all value here. Okay, you don't have the all value here. That's what the margin works for. Last part, the data frame transformation here. So okay, let's go through this part. So what if I just want to create a new column? Let's talk about the addition of the new column. What if I just want to create a new kind of feature? There are 2 ways to do that. I'll just go over the simplest way. So the simplest way is you just specify the df inside the brackets, tell the system what's the name of the new column or the feature you want to actually have. Suppose I want to have a total charge. Then the total charge is going to be day total charge. That's the existing column. Day evening charge, night charge, and the international charge. So I add everything together, and makes that equal to the new kind of frame, which is not in the original data set. Now, I have a new variable, total charge here. Okay, that's a total charge. So that's a way to add a new column. Another way to do that, which is a really tedious way, but in case you want to know, is you generate a new variable, which equals to a summation of all the 4 columns here. Then you can use df insert function. So df insert, first of all, you tell the function where you want to put the new column, where you want to put this new column here. So I'm gonna put a new column in the last, as the last like column over there. So it's gonna be the 21th column here. So I have to take that number equals to the length of the total column. Okay, the length of the total column is 20. So if you specify log into 20, basically it tells them I want to put the column into the 21st position. Okay, that's a location that refers to a location. Then you give the column name. I refer the column name as total cost. Then you give the value. The value is the value here. Isn't that tedious? I think that's super tedious. So I don't really suggest doing that way. Okay, it's gonna give you the same value here. See, total cost. Okay, but I strongly suggest to do it this way. I think this is a super easy way to do addition of the new column here. So how do we actually drop a specific column? How do we actually get rid of some of the columns we don't want? So we can do that as well. So we use a drop function. So use df drop inside. First, you put the columns you want to drop. If it's one column, just get rid of brackets, just use that column name. If it's more than one column, you just use a Lisa here. Okay. And I want to drop total charge, total cost here. Second argument is like, do you want to drop the column or do you want to drop the row? Do you drop along with the column or along the row? So here, I want to drop along, the column. I want to drop the column. So if it's column, you can just type 1. If it's row, type 0. Okay, 0 for row, 1 for column, or you can just type column here. Okay, so in place, that refers to Jimmy's question. If you want to change the original data set, you can refer in place equals to true. Okay, it's gonna change original data set, replace original data set with a new data set doesn't really have those two columns. But if you don't want to change the original data set, you can place that as a false. Okay, so that's basically refer to a difference like a changing or not changing original data frame. Okay, so if I do this, so previously I have total charge, see here, total charge, and also total cost. I believe we have this one here. So if I do this way, disappear. It's not over there anymore. Okay, so the original data frame has changed. So the new data frame now is original data frame because you changed the original data frame. And if you want to change, if you just want to drop specific columns or indexes, not column indexes, you can do that as well. Just do df drop 1, 2. For example, I just want to drop the first and second column, a second row here, first and second row. And so let's just surprise that apart. So I just want to drop that. And since I didn't actually, set in place equal to true here, so it doesn't really change the original data frame. Okay, so if I don't place that here, it doesn't change the original data frame. So if I do that, this is just a temporary result. See, the index only left with 0, 3, 1 and 2 disappear. Okay, it disappears. But if we go back to the original data frame, 1 and 2 is still here. So I didn't change the original data frame. Okay, so this is just a temporary result. Okay, so yeah, that's pretty much everything about my part of the EDA. So 1.6 is more like a practice that left over to all the members here. You can do this on your own. This is about a Kaggle competition of the EDA. You can actually practice a little bit on your side using my notebook here. So I'll try to answer some kind of question here, then I'm gonna be finished. Okay. I can see how pandas would have advantage over SQL over many things, but what are the advantages that SQL would have compared to pandas? I mean, I can come up with one huge advantage of SQL is that extraction on data set is way easier just using like a SQL compared with pandas, right? So if you want to actually extract a specific features here for the pandas, or actually you want to drop or increase the specific features for pandas, it's a bit, I wouldn't say tedious, it's a bit kind of like not that easy. But for the SQL, you just use a select, right? Specific columns over there, you can just do it really quickly. Except for that, I don't really use SQL that much, but I think data extraction for the SQL is definitely the advantage. But data manipulation is definitely an advantage for pandas over SQL. I think that's a difference here. Okay. Pandas is much easier. If you want to join the two data tables using pandas, it's actually going to work as well. So pandas has inner join, outer join, left join, right join, like different kind of joins as well. But I didn't actually cover it here. But later on, I think some of the course leader might cover that part. So basically, all the commands you have in SQL can be actually realized in pandas, but in different way. Okay. Yes, I think that's all the questions I have. Any other questions? All right. If you don't have any questions, I'm gonna actually fade away and leave the stage to Lei to tell you guys more story on the data visualization. If you have more questions, please feel free to reach me, in the chat box. I will try to answer your question over there. Okay. And that's all my part. Thank you so much for attending today's lecture and listening to my parts. And I wish you guys all have a nice day.
Thank you so much, Daniel. It's a lot of helpful information about pandas in Python. I think now Lei will share his screen. Super.
Okay, can you guys see my screen?
Yep.
Yes.
Perfect. Okay, I know you guys are expecting for Chris, but he has a family emergency, so I'll be the substitute. So hopefully I can do my part and help you understand what data visualization is. So I am a data science analytics engineer at Husky Energy. I have been doing data science for 2 years. So before we jump into the data visualization, I want to make a point that through the weekend lecture, we want to kind of lay out what are the overall picture of learning each topic. Same thing for data visualization. So I'm going to teach how to fish instead of giving the fish. So two main takeaway I want you get from this is that first, don't do visualization for the sake of visualization. Secondly, we need to have some basic principles about doing data visualization. So these key principles are the message that I'm going to present on these slides. Okay, before we start jumping into the ocean of Python libraries of doing visualization, I highly recommend everyone to take a read of this classic book by Professor Edward from Yale University. I think it's published in 1980s. It's called The Visual Display of Quantitative Information. So this is the classic book that tells you what is the graphic excellency and how you should make a graphic that to serve your purpose. As the Google's chief economist says that the visualization can help us process, extract value from our data. And most importantly, we want to communicate what we have captured in the visualization to the key business users, and also deliver the right information from the data without any bias. So what are the do's of good visualizations? I know there are a lot of bullet points, but you can either find that book to read, or there are some really good posts from online, basically some main takeaways from that book. So first of all, you need to show the data. The data is the most important in your visualization. And also, other than the data, don't include any other things to extract your readers, and present the numbers in a small space, because the numbers are important, and also make the data set coherent. I think one of the most important thing is that we need to keep the data integrity. So we need to have the proper scale and also the proper way to represent the data in the correct way. That's data integrity in visualization. This is a really good example of a data visualization. So when the cholera outbreak happened in the 1850s in London, there's a famous scientist, I think called John Snow, not John Snow from the famous show, but so in his study, what he used that he collected the data around basically how many patients are living in a neighborhood, and he also made this visualization on a map to show that on the Broad Street you have most of the outbreaks happened near those pumps. Then he presented this visualization with a very objective data set to the decision makers that, oh, we need to isolate these people in this neighborhood and also fix those water pumps. So because before that, there are a lot of rumors say, oh, we have the outbreak and also this cholera can be transmitted by air. But he used this data in an objective way and also presented this data in a very nice format so that people will understand the data very easily and also make the decision in the right way. And there are some other classic use case of using the right way to using data visualization. So here is an example that in Professor Edwards' book, that they basically present the time series data in different locations. So you can tell the air pollution, it highlighted that like nitrogen oxides, carbon monoxide. So there's in different locations, and also what are the volumes and at what time. So this is a very nice way to tell people a story. And this comes to the graphic integrity principles. So as I said, the main takeaway from that book is we need to be objective on presenting our data. So there's no bias. We should protect the data integrity there. And therefore, first of all, we need to make representation of numbers proportional to the quantities. And also we need to be clear, detailed through labeling. If on a visualization, there's no proper label, then it'll be misleading of the readers about the information from that visualization. And also use some standardization. For example, a good way is to use a normalization on your data set so it can show the correct portions. There are also some other very good principles from that book. So like the main message is we need to protect the integrity. This is a very bad example. So this is from the New York Times back in 1978. See here, so they posted a study that what is the fuel economy standards for the automobiles. So it shows that in 1978, the fuel economy was 18 miles per gallon. And then in 1985, it shows 27 miles per gallon. However, if you look at the details, the length of the line in 1985 is about 9 times longer than the line in 1978. However, if you look at the numbers, 27.5 is not even twice the size of 18. Therefore, this graph is very misleading to the readers, and this is not a very good example of protect the data integrity. This is another very bad example, also from New York Times. I think they must have fired that editor-in-chief back then. So this graph shows how much commission that we paid for the airlines compared year by year. So they're comparing 76, 77, 78. However, if you look at this bar, you can say, oh, 78, the commission fees are dropping. However, if you read the context carefully, is that the 78 bar is only show the half year of the fees. So the first two bars shows the whole year's commission fees, but the 1980s bars only use the half year's data. Therefore, it is misleading, and also it is not using the right data. Okay, that's the first of all, the key message I wanna bring here is that for any data visualization, we need to stick to those principles from that book. Then the second part I wanna kind of share with you is about how we can use the data visualization tool in Python to show multivariant visualizations. As you know, in the real world, we don't have a univariant. So any factor is gonna affect our results or our assumptions. Most of the time will involve in more than one variables. Therefore, multivariant visualization is very important. And thus, we need to pay a lot of attention to that. So for example, here, you can see that we can plot a box plots and a scatter plot. On the box plots, you have the customer service calls on at different categories. You have 0, 1, 2, 3. And also you have the churns, as Daniel mentioned in his data set, that some of the customers are churn, but some of them don't churn. But you want to see the internal relationships between the churned customers with different variables. And you also want to compare the relationship between two or more than two variables on a scatter plots. So here on the x-axis, you can see the total day minutes versus the total night minutes. And they don't have a clear correlation. And on top of that, we can also look at each variable's distribution, which can sometimes be important. But this is just give you some example of how you want to do multivariant and visualization so that you can get some valuable insight from your complicated data set. Then after the, when we think about the data set usually have more than two variables, there's another thing that I want to mention here is that because we have very complicated data set, and most of the time our data set, depending on what way we're creating those visualizations, sometimes it can be very misleading. I don't know whether you heard about this Simpson's paradox. It is a very famous phenomenon that in statistics and probability. So the basic idea is that in a Simpson's paradox, when you group the data together, you might find some general trends. However, if you break that group into different categories and look at the details of each group, that trend might disappear. And this can be vice versa. I can show you some example. So this is just trying to have this key concept in your mind that we need to have different ways to interrogate the data, because sometimes the visualization can be misleading. That's why we need to be very careful about the data itself. This is an example. So if you look at this trend, this is a box plot of the expenditures by different ethnic groups. And this is the whole population. So you have American Indian, Asian, Black, Hispanic, and also you have the Caucasian or white, not Hispanic. So on your x-axis is the average expenditures. So if you take a look closely here, you can see, oh, the white, not Hispanic has much higher, this is the median expenditure than the Hispanic. And you can tell maybe there's some discrimination there because the white, not Hispanic can usually spend more money than Hispanic ethnic group. Well, this is the information that we read from this visualization. As I said, the Simpsons paradox sometimes can be very dangerous, because when you break down that each ethnic group into different ages, and then you do the same plot again. So here on the left-hand side, we break down the ages into different groups. So this is the age from 18 to 21. As you can see here, 18 to 21, in this age group, Hispanic spends as much as the white not Hispanic, and there's not much discrimination there. And if you look at the similar graph, but then we look at the age group between 22 to 50, same thing. Like the Hispanic, the ethnic group is very much similar to the white not Hispanic. So this is the Simpson's paradox that I talked about. So depending on the way you're looking at the data, and we need to be careful that sometimes when we're seeing the data in a different way, we can come up with total different conclusions. So there are a lot of ways to solve such issues like the Simpson's paradox. Therefore, the key question is, when we go back to our main purpose of doing data analysis, that we're not creating data visualization for the sake of visualization. We're using visualization as our tool to answer our key questions. And in this case, if you have two totally contradicting conclusions, then we need to go back to the data set to see how they collected the data and why in different age groups they perform very similarly. However, when we group them together, they show some discrimination there. That's back to the basics. Then the last one that I'm going to share my message here is that this is a machine learning bootcamp, and the data visualization will almost serve in every course or every lecture during this course. And I also want to plant the seed here that we're doing machine learning. We all know that we even had a debate around, oh, machine learning versus statistical modeling. And doesn't matter what term or terminology we're using here. The key is that we need to explain such model techniques to the key business stakeholders, like we're explaining to a 5-year-old children. Therefore, right now, it is a very, very hot trend that we, in the open source community, we're developing a lot of model interpretation tools. So the main purpose is that we want to use visualization to interpret the model. We want to see what's inside the model, what are the main factors or main features that affect the model results. And we want to explain that model to our stakeholders, and also we want to explain the potential causality from our model. Therefore, if you're learning visualization, make sure that you need to learn how to use visualization to do the model interpretability. Here's one example. There's a very popular library called SHAP. So basically, this library is to use the game theory to basically interrogate the model you have trained. Doesn't matter what kind of machine learning algorithm you're using, trying to figure out what are the global and the local impact from that model. Here's one example. So from the SHAP library, you can plot. So this is a model that we trained on, let's say, a random forest model, and we wanna know what are the most important features that can affect my model results. So as you can see here, we can plot the feature importance versus our SHAP value, and from it's a ascending order. So the most important factor here is the age. Then also on the SHAP value, you can see that on each variable, we have a high value and a low value. And you can see that if the high value is, if I have a high value here, the impact on this overall model performance is actually lower. However, you have a, and then we have a lower value of age will impact the model output in a different way. So here you can tell a lot of information whether that particular feature is positively affecting your model output or negatively affecting your model output. And you can even look into the details of each data sampling or each row, as Daniel mentioned in his data frame, that here you can interrogate if if a certain feature is trying to increase your predicted value or decrease your predicted value. But we'll talk them into more details later in the notebook. So therefore, as I said, so the main reason or the main purpose that I'm going to lay out here is that we want to show the principles of doing data visualization. And also we want to be very careful about certain traps we might get into by using data visualization, such as the Simpson's paradox. Then I mentioned about the model interpretability is a very important topic, and we should learn how to use visualization to solve that problem. Without further ado, this is one of my favorite quote here. Talk is cheap, show me the code, but don't show this quote to your boss. They like talking. So I'm gonna switch gear to my notebook here. I'm assuming you guys can still see this notebook. Please give me a shout if you can't.
I think there's one question in the chat box.
Go ahead.
It's from Connor Vault. He asks, does SHAP work for unsupervised as well in problems where you don't have any historical labels for accuracy?
From my understanding, I think we use SHAP for most of the supervised learning. So yes, you need to have the historical values or the labels to train the data sets. You have, yes. So that's why, like, when most of the supervised models like random forest and gradient boost model, they need to use the historical data to train that model.
I also have a question.
Yeah.
So when you visualize data to avoid the symptoms paradox, like you break the data into subgroups, right? And then look at the trend. And so when you decide how many subgroups or what feature do you base on to create subgroups, is it only based on your experience, or is there some algorithms for them?
So in that example, it's a very simple example. So in that, I can show you later in this notebook that we kind of look at so we grouped the age into different groups and take a look at the statistical summary of that grouped data frame to see if that is correlated to our the expenditure output. And generally, you can do some statistical analysis based on different groups. And also, and I agree that your judgment or the input from the people who collected those data can be also important as well.
Oh.
But there are some ways to do. I'll show you a very basic ways to group them into different categories and see what are the trends of the statistics.
Okay, thank you very much.
Okay, I assume you can still see my notebook here. I think I have already shared this notebook in the Slack channel. Okay, so when you save that notebook in your Google Drive, one thing you can do is you can run this one to mount your Google Drive in with your notebook. And if you have any issues, we can solve that either in a Slack channel or in a separate thing. to preserve the time, I'll just go through this notebook. So this notebook is adapted from different notebooks. The main one is adapted from the ML course.ai, but I also have found some really useful GitHub repositories here. I've referenced in this notebook, and you can take a look at the original ones if you want. So what we're going to cover here is to talk about the data set and also the plot function from the pandas data frame. And the main library that for the data visualization in Python will be the Seaborn and also the matplotlib. And I'll show you the Simpson's paradox example and also one example of the model interpretability. So first of all, to do any visualization, as usual, we'll import the library. So usually we'll plot the pyplot class from the matplotlib. And then the symbol is a higher level API that is built on top of that matplotlib. But a nice thing about symbol is that it has a lot of default settings so that you don't have to tweak a lot of settings in your graph. So it just if you use the default setting there, you can usually have a very good visualization. So so we'll run this chunk, and this is just trying to import the libraries. Here, one thing, once you mounted your drive, one thing to check what is the current working directory. You can run this chunk to set that, to see your current directory. So I have already set my working directory to this specific project folder, and you can use this command to change your path. And if you don't know Python, you haven't used Python before, you might run into a lot of very silly or simple errors. I mean, from my own experience, it might be at the very beginning, it might be very difficult for you to Google what's going on. I think the quickest way, you can either just have a screenshot of your issue and then ask that question in our Slack channel. Then people usually can help you with that. I know it's very, sometimes if you're a beginner, it's always like we're getting into troubles and we don't know how to Google, but it's normal. So don't be shy to ask questions like those. Then the next thing is we use the pandas read CSV function. Oh, this data set is already in that ML course.ai project folder, as Daniel showed you. So we'll load this data frame. And you can tell we have this many rows and columns. And this is some basic information about what our columns are. So you can see here, we have different types of columns. We have object, we have float, and also the column names. So the first thing is that if we see, when you loaded the data set, if you see some of those, for example, if you see the user's count or the user score, this is an object, but usually it's a numerical value, then you need to change that data type into the proper data type here. So here we can use this function to change the data types. And then, as Daniel mentioned, like this is the list. So it is very useful to use the list to actually group your columns that you want to see. And then you can call that list variable name to see all these columns that what you want to see. As we can see here that have a name column and platform, and yeah, we have different score number there. So one nice thing about Pandas data frame is that it has its own plot method. Usually, by using this plot method, you can do a lot of the visualization about what's going on with your data frame. Before that, I want to mention one very useful concept. It's called list comprehension. So we use a lot, and we almost use this in every project in our daily job, because it's so useful that we can generate a list and use that list again and again. So here is basically, I have a for loop that I iterate between the differently column names. And I have a condition here says, if in any of my column names contain the sales character, I will make a new list that will include this character from my data columns. Before that, I can show you that what is my my columns. So I have this many columns, and I'm looping through all these columns, and then use this if statement and get a list of the columns I want. So I only want the columns with these sales, and this is the list comprehension, and it is very, very useful. And you can find a lot of resources to kind of have a very deep understanding of this. You'll use that in your daily job and also in the interview questions as well. So we use this list comprehension here, and basically we select this list comprehension, and also we added one more column into our list, and we make a subset of this data frame. After that, we group by the year of release. So after we group that, then we do a sum, which is to sum all these values, and then we plot. This is a plot function with the data frame. So as you can see here, when we use a group by, this year of release will become the index, and this year of release will be our x-axis by default. And then it'll plot the figures of different, you have the North American sales, Europe sales, and Japan sales. Then you can see a line chart. Of course, you can also change the plot types. You can change the bar chart, and you can even, this rotation is, how do you want to rotate this x-axis? So 45 degrees, you can do that. And this is the default, this is the plot function that with the data frame. And the symbol, you often see the symbol in almost every data science notebooks, and because it is very useful. And it's a top high level API, so it's very easy to use. The main thing that you can use this symbol libraries to kind of generate this called pair plot, because as I mentioned in my slides that we want to do multivariate analysis, and we also want to see the data visualization. Therefore, the pair plot can plot scatter plot of your selected columns here and plot each other against the other variables to see what are the relationships between different variables. And this can be very useful when you're trying to uncover the relationships between different variables, or if you want to see if any variable is depending on any other variables, because sometimes when we, for example, when we're trying to fit into a linear regression, we want to get rid of that dependent variable. And there's another function called displot. This is from symbol as well, and you can plot a density function on top of the distribution. So this can be very useful too, because when you were trying to understand the overall distribution of your data set, and this is a univariate analysis. Yeah, this is a plot that I show you in my slides. This is a joint plot, so you can plot a scatter plot between two variables and also have their own distribution showing here. Box plot. I cannot emphasize the importance of box plot, but it is a very nice way to have a very good understanding of what are the median, mean, and quartile values of your data set. And also it can be useful to visually detect any of those outliers. For example, these ones, because they're already outside of the 1.5 IQR or the interquantile distance, you can take a closer look of those values to see if they're truly outliers. They can be caused by a data entry error, or it can just be sometimes system malfunction. But this can easily point out that we have some outliers there. I'll continue. So I have 15 minutes left. I'll answer the questions in the very end. So here is a heat map from the Seaborn library. It's very useful because when we're trying to do a multivariant analysis, when we want to see the correlation between each variables, and we also want to plot them. So if we use this function, then it can plot a very nice correlation for us. So I won't dig too much details here. So as you can see here, like we use the pivot table that Daniel just mentioned in his lecture. And also we choose the columns and the aggregation function here. And we also use the fill NA, because fill to do the correlation, to calculate the correlation, you need to get rid of the NA first. So either you can fill the NA values with the 0 or with any other values in your mind. And then we use the Seaborn's heat map to plot this correlation. Okay, this is the example about the Simpson's paradox. And I think I'll upload that CSV file we use to generate this example in the channel. So the Simpson's box is pretty much very common phenomenon in a lot of social science or political science data sets. So because you have different categories and you have different groups, therefore it's very important to keep this in mind and to interrogate your data very carefully. So as I said, I'll upload this CSV file to you later. So we read the data, and here we use the box plot from the Seaborn, and we choose the y-axis as our ethnicity, and then the x is our expenditures. The data will be the data frame. So the data frame here is because we want our visualization to kind of have a in a sorted fashion. So we can use this sort function on this data set. And this is some format that you can change yourself in this box plot function. Then you can set your title, your labels. As I said in my slides, the labels are very important. So in your practice, make sure that you have the right label so that you can deliver the right message. So if you run this is the total. So this is the expenditure versus different ethnic groups, and this is the total or the average expenditure considering all the age groups. And then here, back to answering Jane's question about how do you know that we might have a Simpson's box issue. So here, as I mentioned, we can use the group by to do some statistical analysis based on various groups. So here we select, this is the log function that Daniel just mentioned in his lecture. So we select these two columns, so the age and also the expenditure. Once we select that, we group by the age, and then we calculated the average values and sort it. So when we run this function, it'll give us a summary table about what are the average expenditures in different groups. As we can see here, there is a general trend here. As the age groups becomes older and older, you can see that the expenditures are becoming more. So in this way, you can see that there are huge differences in different age groups. And then this will tell you that you need to break down your expenditure analysis into different age groups. And this is making sense too, because from our common sense that the older you are, you're probably gonna get richer and you'll spend more. And then this is how we're trying to build our visualization based on different groups. So here I have a category list. So I have a list from 0 to 5, 6 to 12. So all these list groups are they similar to my age category here. And then I kind of specify which. So I'm going to loop through all these different categories. So here I mention, oh, let's try the first group. So when I say 0, which means the first element from that list. So here I may make a new data frame because I don't want to use my original data frame. So I make a subset from my original data frame and give it a new name so that this is my new data frame, and everything will based on this new data frame that I'm going to use. So here, same thing, I want to do a box plot. Here, I just want to mention one thing here is that I use a where function. So the where function is, if you're familiar with SQL, is to where you pass your logics. So here I pass my logic that I want my age group. So here is my my age group. So here you can see my age group. I want my age group equals to the category that I selected. So I selected category list num. It would be category 0, which means my first element from my list. So therefore, in this case, I'll translate into English is that I want to see my DF's age cohort equals to 0 to 5. Everything else will be the same. So when we plot this figure, you can see that this is the data from the condition that I'm interested in seeing the age group from 0 to 5. And if we want to change, I want to see my second list from my category, second element from my category list, then you can change to 1, then run this again. See here, my title changed. I want to see the distribution for my age group from 6 to 12. So you can do this for different groups. You can have a for loop here to generate different box plots. But as you can see here, from the age group 6 to 12, my Hispanic box distribution is very similar to my white distribution. As a matter of fact, the Hispanic has a little bit higher expenditure than the white group. So this is what I mentioned about. This is the Simpson's paradox that we really need to be very careful, and we want to reveal such issues in our visualization. Okay, to the last part, model interpretability. As I mentioned, there are so many ongoing researchers and also open source tools that are trying to solve this issue. So here I'll for the sake of time, I'll just focus on the SHAP value because you probably will encounter this a lot because this is intuitively easy to understand on the visualization, and also because we have in machine learning we have built a lot of tree-based models and you name it, random forest and XGBoost and light GBM. So this is very helpful when we're trying to explain those models. So as I said, I have referenced the GitHub repository here, and there's also some instructions on here. So here, because the SHAP library isn't come with the Colab by default, so you need to install that library. So here you can run just here pip install SHAP, then install the library. Once it's finished, we can do the same thing, import the library. And one thing I want to mention that to practice your machine learning skills, sometimes to get the right data is a little bit challenge, but in the sklearn library, we have a lot of data sets that you can actually use. So so if you can look at the sklearn documentary, there's a data sets class. So in there, they have a lot of data sets that you can use to practice your machine learning skills. So here we load a data set called load Boston. This is the Boston's housing price data set. And we also load a random forest regressor, which is a random forest model technique. And then for all of this, we would learn them in details in later lectures. But here I just want to show you how we can build a model and then interpret that model. So here we load all those necessary libraries. Oh, I think I restart my runtime here. Oops. That's the one thing that I don't want to do is to do the live coding. It's scary. Anyway, I think I need to install my my library. It's this one. So it should install very quickly. So install the SHAP library in my current runtime. And I think it's finished. And nice thing about, so whenever you see this red lines, which means this is the error that happened. So it can help you debugging your code. Then we run this chunk. It should work. I think it's loaded. There's no error message. And then we load this Boston housing price data set. So if you, in that, there's a method called description. So you want to know what is that data set you're loading, then you can use this .descript, which will tell you what the data set is about. So as we can see here that this data set is about Boston housing pricing, and also it gives you the information of each column. So the, in different columns, they have a abbreviation. So this is a per capita crime rate. And the RM stands for average number of rooms for each house. And you also have the percentage of lower status of the population, which means what is a percentage that, there are some, if there are a lot of unemployment people in that area, this percentage will be higher. So this can be very helpful to understand the data. So to do any machine learning, first thing you need to do is to understand the data set before you do any machine learning. Okay. Once we have that, we can have a basic, statistical understanding of the data set there. Here is that basically I split the data into train and a test, and then I use the random forest model to train my data. So when I fit my train and my target, I'm training a model. It's already finished, so it's very quick to train. And then I need to evaluate my model. So the reason is that we have a separate data set. So I want to know how good my model is. Then when I need to use that model to predict a data set the model has never seen before. That's why we have that train test split. So when I run this thing, it tells me that my training score is about 98% and my test score about 90%. It's a fairly good model, but we might have some over training there, but that's not the point of this lecture. So here is the important part about the SHAP value. So the SHAP value is for us to interpret the model. So we need to load the explainer from this package. And now here is very simple, a very simple function there. So as you can see here, the explainer, we passed our model. So the ref/reject, this is our trained model. We passed this model into the train explainer. And we also passed our training data set to our shape values. Then we use this function to plot. So this is the function that we're trying to help us understand what's going on with our model. So here you can tell that the most important feature is the LSTAT, which is the proportion of the, I would say, the lower income people of that population. And you can see here that the lower of that rate in that area will have a higher housing price, which makes sense because most of the best neighborhood will kind of have people that usually have incomes and they're rich people. And as you can see here for the room, usually the more rooms you have, the more expensive the house will be. So this will tell you a very good picture of what's going on in terms of feature importance. And you can also plot in a very, traditional way, which is just show you the bar chart here. And last, and there's some other important visualization from this package is that you want to say, what's the correlation between my certain variable versus my final output results, and also to show you what are other dependent variables to your particular variable. So this will show you that this is dependent to the DIS variable. And here is the kind of interesting graph here is that, see here, I am trying to understand for my first row, I want to understand why, so this is my base value. This is my predicted value. I want to understand why my prediction is higher than my base value. So what this shape package gave us that how it calculates the base value is to use your average value. So here it used the average. So the average value of all of your variables. So for example, here for this row, my LSTAT value equals 4.98. It's much less than my average value. Therefore, which means this is a very good neighborhood. That's why it is increasing my house price. And however, my room for this particular observation is that my room number is smaller than my average room number of this whole data set. Therefore, it is decreasing my predicted value. So this will help you to understand what are the driving factors for each row or each observation for your final output. I think I'm gonna stop here to see if any questions. I don't wanna, take a lot of your time. So I'll stop here. You can run this notebook and you can ask any questions in the Slack channel as well. I'm ready to answer some of these questions. Let me take a look at the chat box. Okay. Can I talk about another way to evaluate model performance? So the model performance, how you evaluate. So depending on what your model is trying to solve. So we have classification machine learning models and also have regression machine learning models. For classification, we really need, there are some metrics like you heard about, ROC curves and the recall and precision. And those are very important because depending on whether your data set is balanced or unbalanced, you need to use different metrics to understand what your model is really doing. I think those ones I can post some blogs in our Slack channel to kind of show some examples.
There's another question that's not answered by anyone else in the chat box yet, which is from 3:38 p.m. from Connor Walt. He asks, is list comprehension significantly faster than a normal for loop to create a new list?
I haven't well, it's just a cleaner way to build a new list. So because it's very because you're iterating inside your list, so it's usually much cleaner to express that way, because you don't want to write a, because one thing to notice in Python is that it's highly dependent on your indentation. So whenever you write a for loop, you need to be very careful about the indentation, but with the list comprehension, you don't need to worry about that. And it's just a much cleaner way to write code. Any other questions? Yeah, I think we can call it a day, and yeah, we can just always post those questions in our Slack channel. And yeah, I just don't want to waste your time, and it's been 3 hours. So yeah, anyway, I thank everyone to joining this our first lecture, and I hope you have learned something, and also thank our head instructor to put this together. And we will be sending out some post-lecture surveys to help us improve the quality of the lecture. So keep tuned on that. With that, I think we can, yeah, we can conclude this lecture.
One more thing to mention is we don't have class on next Sunday because it's Thanksgiving holiday.
Yeah, that's correct.
Yeah, yeah. Before everyone leaves, let's take a group picture. Like if you can turn on your camera, please turn on the camera and